If you're working with a Vast XT or a Duramax with a fixed head, you have to use star probes, and on a part like this you don't have the luxury of a RDS rotating head to get into all these different angled holes. So even though I have a very small star probe set up here, it's going to be hard for me to get all these angled holes that I'm looking at here. I'll just go and extract features to show you. These are the holes I'm interested in right now, and trying to get the size and position of those holes. So as a workaround, what you have to do, or what you can do, is you can measure them off of gauge pins. It's not the best approach, but it is something you can do. So we're going to change our probe here, and we're going to use a down probe. Let's say we use a 2x40. It's a little bit large. Maybe we'll do a 1mm. See if we can find one. Here we go. Z1x20. All right. So if I go define points on the simulator, I can move this probe around, turn off the trails. So that's a good size probe. And the idea is we're going to insert a gauge pin into the hole before we measure off of the gauge pin directly. And this also applies, this approach applies if you're using a true pause locator or a Joe plug on a threaded hole. So the first step is you're going to extract the cylinder. And then you'll go into that cylinder. And right up here is the inside outside switch. So we're going to flip it inside out. So now it's an outside diameter. And then we need to go to the strategy. And we're going to go to the circle path, and we need to do a circle path that's 180 degrees. And we're going to change the start height. Now this start height is relative to where your cylinder begins. So you'll notice this local trihedron. This is not your base alignment or any alignment per se. It's just where that cylinder begins, the base of that cylinder. So this start height is relative to that right now in millimeters. And we're going to start farther out. Let's say we go about 20 millimeters. And we're going to do one circle path at a time. Now that's too far out. So we're going to go farther back. We'd like to be as close to the opening of the hole as we can without hitting the probe. That looks pretty good. So since we're doing just one path, the target height doesn't matter, because if I change this, it doesn't do anything. We're going to do two separate paths in opposing directions. So then we set our speed. Right now we're measuring a 2.5 millimeter hole, and we're doing only half of the diameter. So we'd want to go maybe 2 millimeters a second or less. I'll just go 1. And then number of points, 500 is a little bit overkill. We'll go 300. Okay. So now we're going to copy this circle path. I'm going to change the start height where it begins, and let's say we'll go 12 millimeters. Now the reason why we want to do this in the opposite direction, first of all, it saves time. So it's going to scan this way and then come over here and scan the opposite way instead of having to leap over the part. Also, occasionally the software thinks it needs to go underneath the gauge pin. So we want to prevent that problem. So we're going to change this to -180, and then the start angle is 180. All right. The next thing we need to add in is some user prompts so that when it goes to measure that hole, it's going to ask you with a little message to insert the gauge pin. So right in here, we're going to go put in a programmable stop right after the first clearance data. And we're going to say insert gauge pin. And you could tell you could tell the operator what size. Maybe we would do 2.5 millimeter gauge pin. Most gauge pins are in inches, but yeah, you could convert that. So then you have that stop, and then you could put another stop at the end to say remove the gauge pin. That way, if the program is going to measure anything else where the pin would be in the way, that would be removed. Okay. Now let's see it in action, how that works. I just set up my base alignment and clearance planes. So now we're going to right click on the cylinder and execute to see how this works. And so it goes, notice the probe went up to the clearance plane, and then here's the message to insert the gauge pin. So you put the pin in there, make sure it's snug, but it's not going to be too tight where you're wiggling the part out of location. And then we click continue run. It's going to measure off of the pin. And then it will prompt you again to remove the gauge pin. And then it's all done. Oftentimes I like to give a little bit more room between the probe and the gauge pin or the true position locator so that the probe is farther out of the way when you get those prompts. And one way to do this is to go to create some sub-clearance planes. So I'm going to plan, navigation, sub-clearance, and then new, and then we'll say this is sub-clearance plus Z, and then this is going to be above the regular clearance plane, and we'll say 100 plus 100. Okay, and the parent group is CP plus Z, and we're retracting to the inner plane 100 millimeters above our Z0. It's not really an inner plane, it's an outer plane, but you can still do this. And then you'll notice that's where it's going to move the probe. So it has plenty of room out of the way. Now, when I go to my cylinder, I can assign that clearance plane, or the subclearance plane, and it's going to use that instead. So let's test that out. So you'll notice it did not go to that clearance plane as I expected, and I purposely did it this way to show you that you have to put in a double clearance plane. It's kind of a weird workaround, but I'll show you that right after this. So it did go to the subclearance plane at the very end, but not at the beginning. So we'll go back in here, strategy. We're going to put in another clearance data right after the first one. And they're both going to be subclearance plane plus Z100. And so this is going to force it to go up here at the very beginning. Also, I'm going to put another one right after the last circle path, just so that I have room when I want to remove the pin. Okay, not that. We want another one of these. Okay, so you have two at the beginning, another one right after the last scan path, and right before the last user prompt. So let's see how that works. I just want to make sure, I'm going to remeasure this plane right before it just to make sure it goes to the regular Z plane and then it goes to the other feature after that. Oftentimes when I'm testing, I like to do consecutive features just to make sure the flow is working. So let's run those. It's going to do the plane, and then it's going to come do the cylinder. Notice the probe went way up. You can't even see it right now, but now it's coming down. And there we go. It's out of the way. So anytime you're doing a measurement off of a pin or a true position locator, you got to put the double clearance plane using the sub clearance plane that's farther away from the regular one. And then you do your programmable stop, circle paths, another clearance move to force it to go away, and then one more programmable stop for a message to remove the pin. So I hope that tip helps you guys, and you have a great rest of your day.